Welcome to my second video on how to create a home network using OPNsense. In my first video, I showed all the hardware that I plan to be using to create this example network. And in this video, I plan to set up OPNsense on my VP2410 mini PC appliance here. And if you wish to follow along, you'll need to have similar hardware. You're going to need a USB thumb drive, and you're going to need to be able to connect your box either to a monitor and keyboard or the console port connected to another computer using a USB cable. Either way will work, but I will talk about both methods as I go along with the installation of OPNsense. Once we have OPNsense installed, we will configure the rest of it using the web interface. So let's begin. The first thing we need to do is to download OPNsense. If you go to opensense.org/download, you'll see this page that you have before us. The only architecture option is 64-bit, AMD 64. So OPNsense will only run on 64-bit software. It's just like pfSense that both projects have abandoned 32-bit compatibility in favor of 64-bit, since most modern day hardware now runs 64-bit hardware. Even devices such as a Raspberry Pi have gone 64-bit, right? So for the image type, there's several images. You'll see nano, DVD, VGA, and serial. DVD image is useful if you're using like a mini PC or a micro PC or whatever, a desktop PC as your router firewall appliance. Even though those are some of those options are a little bit less efficient, you could use existing hardware. And if you have a DVD drive in it, you might want to use the DVD option. It's just basically an ISO image. For most users, they're probably going to use the VGA option. If you're going to use a thumb drive, it's like we're going to be doing in this example, and you have a monitor and keyboard plugged into your device to install OPNsense, you're going to want the VGA option. If you're using the serial console, whether it's USB or other type of console, you'll want the serial image. It's so that it'll actually load your display properly. So those are your main options. So we'll pick VGA, and then you can pick your mirror where you want to download it from, depending on what country you live in. You might want to pick one that's closer to you instead of the default option, which might be in the Netherlands, where OPNsense, the company, is based. So basically, you're going to click download, and if you really want to verify the checksums, you could do that. Here's the hash right here for it. But I'm not going to bore you with the download. I already have it downloaded. So I'm going to switch over to Etcher. I like to use Etcher for my USB flashing, because it's just a nice utility. It's really easy to use, just 3 steps. You basically pick from the file. You won't be able to see this box come up, but I'm going to pick, once I find it, I want to pick my OPNsense that I already have pre-downloaded ahead of time. So let me do that real quick. So I'm going to get distracted here, and I pick the VGA option, right? You'll see there's the image there, and then I'm going to select target. I already have Ubuntu installed on this disk. I'm just using this as an example. Flash drive, you'll see all your flash drives that you have plugged in will show up here in Etcher. You just select the one you need, and then you click the flash button. I'm not going to actually do it because I already have that step done ahead of time. But once you do that, it'll go through and write to the disk, and then it'll verify that everything looks good. So once you have that done, you just plug the USB flash drive and your monitor and keyboard into your device or serial console, and to continue. I'm not going to show the serial console step. There's an extra step involved in that. You have to have software that you can do serial consoles with. You can do it with Putty or Termius, and applications such as those will work just fine. Before we get to the OPNsense installation portion of this video, one thing I'd like to mention that I discovered when I was going through this installation process, and I actually re-recorded this section because to make this more clear, this installation that I'm going to be doing is not going to quite follow the written guide that I have for setting up a full network using OPNsense, because I assumed a normal AMI standard BIOS because I actually did it in a virtual machine to make it easier for me to get screenshots. But that process I wrote about is like what you normally would encounter and expect for OPNsense. But I noticed when I use Coreboot BIOS with like my Protectli VP2410, and if you have any other Protectli models with Coreboot, you might experience this as well, that the boot process is a little bit different. So that actually affects the OPNsense installer. So you'll notice in the screens following this that when you get to the boot screen of OPNsense installer, it normally has like an ASCII graphic text that says OPNsense and some other information on there, like pressing a key to the configuration import and that kind of thing. But it just looks like question mark gibberish, and then it skips that portion, and you don't get to do any kind of preconfiguration of OPNsense before you get to the prompt to start installing. So that process I walk through it on my website, and if you want more details on that, you could go through there. But I'm going to do it this way because that's what I have installed on my machine is Coreboot. So without further ado, let's get started with the OPNsense installation, and we'll see what I'm talking about as we get into this. Okay, now I'm booting up my OPNsense box, and I'm going to hit the delete key to enter the setup process. You could hit the F11 key to get the boot menu to pop up, but I'm using a screen capture, IKVM type, KVM over IP, whatever you want to call it, with TinyPilot. So I don't want to hit F11 because it'll take me out of my browser and minimize what I'm trying to do here. So I'm just going to go through and show you if this is what the Coreboot menu looks like for the Protectli VP2410. There's an option here for a one-time boot, which will be the same thing as hitting F11. And you'll notice that I have a Protectli USB drive in here, and it's abbreviated as Protect for short. So we're going to click on that, hit enter on that key. And here's the question mark menu that I was telling you about. It's supposed to say OPNsense and all kinds of stuff in ASCII text, ASCII graphics, I should say. But now we're going to boot this up. And normally it would walk you through the configuration process like I mentioned earlier. But it's actually skipping all that, and it's going to take you straight to a login prompt, and that's where we can do our normal OPNsense installation. So we're going to do that installation first, and then I'm going to reconfigure some of the default interfaces because it's going to put them in the opposite order that we want them to be in. It doesn't really hurt anything, but I like having the WAN interface as the first interface, and I like having the interfaces 2 through 4 to be the LAN interfaces. It's just easier to keep track of instead of having the WAN interface plugged in one of the random ports in the middle of I don't know. It's just a matter of preference. But I'm going to do that because it'll match the written guide, and it'll also match what I showed on my first video of this series of how I have everything connected together. And as you can hear in the microphone, the Protectli box actually makes a little musical tune, which is kind of cool. It lets you know when you're booted up. That's pretty handy when it's in my server closet over here. When I reboot, it makes a little tune, and then when it boots back up, it makes a tune. And so I know just by listening that, oh, it's booted up, I can log in. I don't have to guess, keep trying the web interface, see if it's going to come back up, because I can hear it. Actually, it came when it comes back on. And that's kind of a feature you can actually enable, disable in OPNsense. You can turn off the beep tones. Not all of these little mini firewall PC appliances actually have a little speaker in them like the Protectli does to actually make those little beeps and sounds. So that's one kind of a neat little feature that, nice to have, I think, if you like it. If not, you can turn it off. Okay, so now we're at the login prompt. We're going to type installer as the username. If I'm actually clicked on the screen, since I am using a screen capture program, I gotta make sure I'm clicked on the right screen. Okay, installer, and then OPNsense is the password, default username and password. By default, it's going to use the US keyboard mapping, so you can say enter if you're using that. You're going to have the option for UFS or ZFS file systems. In general, it probably doesn't really matter which one you choose, but ZFS has some more robust features. Even if you're only using a single drive, you can still take advantage of snapshotting the file system. Some people like to actually take a snapshot of their file system before they do an update. So then if an update kind of goes sideways, goes wrong or whatever, they can actually just revert that back to that snapshot and the entire file system and get back to where you were before the update. This is probably a very good option for you if you're not using virtualization and virtual machines and you are doing a bare metal installation. Normally I would recommend, just backing up your config file, but that doesn't capture everything. And a snapshot restore might be way quicker as well. But it wouldn't hurt to have both. You can have your configuration file as a backup, and you can actually just revert back to the ZFS snapshots. So let's install the ZFS file system. Since I just installed this in a previous run of this video, I did have it cleared off. I'm just going to roll with it, but it's going to say zroot is already taken because I already have a ZFS file system installed on my box. So I'm just going to replace it because this was just one I just did in a previous video that I am not going to keep because I had technical difficulties. So you can do a stripe mirror or any kind of RAID Z whatever structure. For most people, for a firewall appliance, you're either going to do a stripe or a mirror. Stripe is if you only have one drive. A mirror if you're going to do 2 drives. You can do more drives if you have 3 drives or whatever. But for the Protectli VP2410, it actually supports 2 drives, 2 SATA drives. So you could actually do a mirror in that box. So we're going to do stripe, and the drive that's in there is an M.2. It's a Protectli branded drive because I got it from Protectli. So the first drive here, to select it, you just hit the space bar. It doesn't tell you anywhere on the screen. You'll see down here that you can see the 8 gigabyte eMMC drive that comes with the Protectli. You can install in there as well, but I don't think 8 gigabytes is enough, especially if you're going to do logging and stuff for the firewall. But we're going to go next, and we're going to say yes, let's destroy that. You're always going to get those kind of warnings when you install an operating system in general. So you'll see that it's cloning the current system. The cloning process actually is pretty quick, as you'll see. It actually takes a little bit longer to verify the file system than actually clone it and install it. I'm using a USB 3.0 thumb drive connected to one of the ports on the VP2410 are 3.0 USB 3.0 ports. So that allows the installers to be a little bit quicker than a slower thumb drive. I haven't actually benchmarked the thumb drives. I probably should. In my accessory review, I could benchmark it and see how fast it actually is. It would be worth checking into. This is actually, the process is quick enough. I don't really need to even skip it. I can just talk a little bit through it and have this done. So this will be done very soon. What's going to happen next is it's going to prompt for changing the root password before you reboot your OPNsense because it's finished installing. So I recommend, if you can, to change your password right away. But if you're not connected to anything, you can always change it in the web interface later. You just gotta make sure you don't forget because that's important security. I'm glad they prompt you for that before you finish the install because that's nice. So we'll do that here. We'll just hit enter. I'm gonna type in my root password. Trying not to mess it up for the video. It just takes a few seconds and it'll come back to the same screen, and then we can just say continue. Complete install, right? So now it's actually going to reboot, and it says that the OPNsense web interface is going to be available at 192.168.1.1. That's actually the same default IP address range you'll see in a consumer grade router. So if you are transitioning from a consumer grade router to OPNsense, this part should be very familiar to you because it's the same IP range of your devices. So when you plug in, so I'm hoping this will, so when you plug in, you'll have the same IP ranges. I'm hoping it's actually going to boot into it and not off my USB drive. You can kind of tell maybe if it's booting a little bit faster than the USB drive. That's kind of one general indication. But what the easiest way to know is if you use the root username and use your new password that you just put in. If it logs you in successfully, then you know you're not booting off the USB drive. Because I didn't want to bother taking it off. It's behind me, but I don't really need to take it out because I didn't make my USB drive my primary boot disk. That's why I kind of like doing the one-time boots because I don't do it very often, so you don't have to worry about it always booting into it every time. And after it gets past this PF log, there's the beep tones. Okay, now we're at the login. So let's do the root user, and we're going to use the new password that we typed in, and see how it logged me in. So now I know that I'm not booting off a USB drive, which is really cool. It's what we want. One thing we're going to do before we do the log into the web interface is we're going to change the assignments of the LAN and WAN interface, because by default, as you can see, IGB0 is actually interface 1, IGB1 is interface 2, how it's labeled on the box. It's labeled 1 through 4. IGB0, we want that to be the WAN. I always like making the first interface the WAN interface, and I like to make the interfaces 2 through 4 my LAN interfaces. So I'm going to swap these two interfaces, and I'll show you how to do that before we log into the web browser. And then we'll do the rest of the configuration through the web browser. So as you can see with the menu options, we want to go to menu option 1 to assign interfaces. Normally, if we would have walked through the configuration like how my written guide was done, not using Coreboot, these interfaces would already be in the correct order, and then we would just go right to the browser. So it says you want to configure lags now, and we're going to do no. We'll do that stuff in the web interface. And no VLANs. Okay, so now it says enter the WAN interface name. So we have 4 interfaces, 0 through 3. The Protectli boxes are pretty straightforward because 0 is 1, 1 is 2, 2 is 3, and 3 is 4. We're just going to go with IGB 0 for the WAN. Okay, and then for the LAN, we're going to do IGB 1. And so optional, we can set up optional interfaces for the third and fourth port, which is IGB2 and IGB3. We could do that here, but I'm going to do all that stuff in the web interface because since we're doing a LAGG, I don't want to do all that configuration through the command line. You can do that. I just want to show how to do all this stuff in the web interface, because that's how most users are going to be configuring things. So what we're going to do for the optional interfaces, we're just going to say just do nothing. We're going to say enter. And so that way we're just reconfiguring WAN and LAN. Notice at the top of the screen, LAN was IGB0 and WAN was IGB1, but now at the bottom here, WAN is IGB0 and LAN is IGB1. So that's what we want. So we just basically swap them. And so luckily, just by swapping the interfaces, any of the configuration that was with the interface by default before, like the LAN, it actually still has it, which is nice because we don't have to change IP addresses for now. I'm going to leave them the same for the LAN. I'm just going to use the defaults for that. So that's great. So now we got those interfaces swapped. At this point, we're ready to plug in to the LAN interface. So I want to show you the physical connections that I'm going to be using to actually configure the remaining portion of this OPNsense guide. I'm using the GoIn R86S box that I have here as a Ubuntu desktop. This could be your laptop or PC or whatever device. It's just convenient for me to use these little devices. This is my VP2410. The first port is the WAN interface. The second one is the LAN, and the other two are going to be our LAGG that we're going to create that has only the VLAN traffic. So we're just going to plug this port. We're going to plug it into port 2. And once you connect this here, we're going to do all the configuration on OPNsense first, and then we'll eventually, in the next video, we'll do the network switch. So now we're over on our little mini PC here that we're using to configure OPNsense. First thing you might want to do is, you can't judge by this icon if you're connected or not, because you're not connected to the internet, so it's going to probably have a question mark there. But if you do IPA space A, you can actually see, if you're using Linux, you can actually see that we have a valid IP address of 192.168.1.100. So that's a good indicator that we're connected to the LAN network. And now we can type open these IP addresses in here. I've logged into different configurations with different ports and stuff. So basically type in 192.168.1.1 and it should redirect you to HTTPS. So we'll be configuring our OPNsense firewall box, accept the risk and continue. I have this saved from where I've been playing around with other ones. So Basically, you want to type root as your root user. And you just enter the password that we entered during the installer. So let me just say don't update. So when you first log in OPNsense, it'll want to take you through this wizard that you can walk through several steps. You don't have to do the wizard. What I like to do is skip the wizard and show you where the actual settings are, because if you want to change this stuff in the future, you won't know where they're located based on the wizard, because you can always rerun the wizard if you want. But I think it's better to learn where the settings are located than to rely on the wizard. Maybe if you're a first-time user, you can walk through it. It has a good basic set of general system settings you might want to tweak right out the gate. You know, a lot of the settings for the wizard are located in the settings pages. So we're going to look at settings, general, system settings general page. So this is going to be our host name for your box. For your OPNsense box itself, you can give it a domain name basically, or a host name, and a domain name for your network. So for the host name, I like just calling it this what it is, right? A router, or whatever. It's also a firewall too, but we'll just call it router. And by default, it does local domain, because you don't want to do you don't want to call it local by itself. You don't want to do this because a lot of domain names used a lot for like local discovery and stuff like that. So it'll conflict with all that stuff. So you don't want to. It'll conflict with all that. So let's just do. I'm going to do homenetworkguy.com. Little plug there, right? For a website. You can use whatever domain name you want. You could use real domain names. Like I own my own domain name for that I use for my network. That is also a real domain name. So I like doing that because you can have internal and external host names. So you can just resolve between them seamlessly, and you can do split DNS and those sorts of things, which I wrote about on my website. So I like using real domain names, but you don't have to. You just got to make sure you don't pick one that already exists, because you'll get conflicts with DNS, right? If you pick like Amazon.com, you don't want to do that. You won't be able to go to Amazon probably if you do that. And then just pick your time zone. You can change your time zone. I'm just going to leave it for this purpose. You can change it to whatever you want. There's some different themes you can pick if you install them. Out of the box, there's no themes installed, but they do have dark themes. I know a lot of people like dark themes. So this might be confusing for some people having a DNS server. This is what the system will use because there's several places you can enter DNS information in OPNsense, and if the system settings DNS servers, and on this page is what the system OPNsense itself will use as its DNS. So by default, it says allow DNS to be overridden by DHCP or point-to-point protocol on WAN. So by default, if you're connected to your ISP and you have your WAN connection to DHCP, it'll use whatever servers your ISP uses. And so that's something you may not want to do if you want to tweak your own DNS. But for now, we can probably just leave that, because if you plug this into your network, then it'll use the DNS of your network, whatever network you're attached to. So it'll use that as the gateway, which is fine for our purposes. But I'll come back around later and we'll tweak the DNS settings later. But for now, we'll just leave that and we'll just hit save. Okay. And then we'll go to the administration page, settings administration. And you'll see it's set to HTTPS by default. It already has a certificate generated, self-signed certificate, which is fine. You'll get warning messages. There's ways you could probably create your own if you really don't want that. You can do HSTS, the HTTP strict transport security. You can enable that to get extra security. So people can't hijack your HTTP sessions as easily. Disable web GUI. We don't really need to do that. Let's see. I'm trying to see if there's anything else you want to do. You can do some HTTP compression. So this is one thing that I recommend changing. If you want to have extra security, you can set the OPNsense web interface only listens on the LAN. We don't have any other interfaces configured right now. It says I know what I'm doing, so I'm going to click that. But we're going to only allow it to listen on the LAN interface because that's going to be our management network. So that means we can only configure OPNsense through the LAN interface. If you really want to, you can allow devices on any network to access your OPNsense interface. All you need is a firewall rule. But at least it's not listening by default for any device to connect to it within each network, each interface that we're going to create for each network. I like to change that setting for extra security. If you want to allow SSH, which I recommend doing SSH, so you can have another way of getting into your box if something gets messed up with the web interface, you need to restart something or whatever. You could use root login if you want, but if you do that, I recommend using a key. So if you use a root login with a key, it's a lot more secure than allowing, if I hit permit password, this is the least secure way of allowing access for root. If you're really paranoid, you can create a separate admin account and don't permit root at all. But one thing to keep in mind, which I wrote in one of my guides, is you don't get that nice menu of options to help you walk through some settings in OPNsense. If you don't use the root user, if you use another admin account, you don't get that nice menu. So that's one privilege of being a root user, get those extra options. So let's uncheck that permit password, but we'll allow root login, but we'll have to set up a key. Right now, there's no key. You have to go into the user and add a key, SSH key in, which I won't really go through right now. But we'll come back around to that maybe circle back around and afterwards when we get all the videos done to do some of these extra features here. The console driver is the VGA. That's how we set up OPNsense. We use the VGA console driver. You can actually set up a secondary one if you want to allow serial console connections, so you don't have to have a monitor and keyboard plugged in anymore, which I unplugged mine. I'm planning to use this SSH and the web browser. That's not two main ways I access my box. I don't really connect the VGA once I get it set up anymore. And actually, I like to use the console to actually install OPNsense as well. With USB console is pretty nice. But anyway, so this page is not really much to change. There's a couple extra security things that we enabled. We enabled SSH because I think that's important. So once we do that, we'll save that. I'm trying to go through some of my notes here to make sure I include everything as I go through. Just reloading. It shows us even though we didn't really change any settings that would cause like we didn't change the port number or anything like that, so we're not going to lose access to this page. We didn't change it back to HTTP or anything like that, so nothing crazy there. Miscellaneous. The miscellaneous page in here is helpful for if you want to do thermal sensors. You need to change this to this system has an Intel processor, so we want to choose the Intel. If you don't pick this setting here for your thermal sensors, you'll get like one sensor reading and it stays the same, and it's not really your CPU temperature. I'm not sure what it is, if it's ambient temperature or if it's just some value that it just randomly gets frozen on. I'm not sure. It's actually not helpful at all. So you definitely have to pick the thermal sensor hardware. That's the most beneficial here. You can do some periodic backups of some of your reporting and stuff here. Power savings, this option is actually interesting to use. You can use Power D and do high adaptive, which is the default settings. This allows you to get more performance And since it's adaptive, it'll actually kind of ramp up your CPU and then ramp it back down. So it tries to save some power. But you can actually set it on like minimal if you want to, use minimal power, but you don't care about performance. But for firewall stuff, you probably want the max performance. These devices are pretty energy efficient anyway. But I feel like I haven't tested it thoroughly, but it seems like to me you can maybe crank out a little bit more performance by using PowerD, because I feel like it allows the CPU to kind of ramp up and down a little bit more. Because I think without it, I don't know if it actually does it, because you can look here at the setting. It says it monitors system state and various power controls, so it kind of does some, I think, some more automatic adjustments where instead of keeping it at the same level all the time, I think, if you don't have it enabled. So I played around with that. I think it does actually help a little bit. If you want to change, do some stuff with swap files, you can do some of that stuff here. I'm not going to go through all the options. I'm just trying to do some of the bare minimum options to kind of get started. I went through a lot of these options. I went through my guide and actually took notes on what I want to change for this video, because I don't have time to do like a ton of settings. That's why I'm going to circle back around, and we can kind of tune up some stuff and make it a little more secure later. Okay, so those are just a couple options. I didn't really tweak a lot there. There's just a few little things that are helpful to change there. But now we can actually just get right into the some more of the meat of this finally, right? You're probably like, why didn't you do this quicker? But I want to explain things in detail like I do my written content, so that you can have a better understanding of this stuff. So if we go to the interfaces menu, you'll see we just have the LAN and WAN that we configured by default. So what we need to do now is actually go to other types. So since we're going to create a LAGG, because we already got the WAN and LAN, we just need to configure the other two interfaces now, the remaining two, and we're going to create a LAGG in it. You don't have to create a LAGG. If you have 1 gigabit appliances, it's a good idea to probably do a LAGG, because I feel like it's well supported. Even works with I feel like it works well with ZenArmor and some other things like that, whereas sometimes those interfaces don't maybe work out well with maybe the LAGGs and stuff like that. So with some of the IDS, IPS, because of NetMap, all those kinds of things. There's a lot of things at play there. Since the interfaces are slower, if you have 1 gigabit interfaces like the VP2410 that we have back here, creating a LAGG can give you a little extra bandwidth. It only helps you if you have 2 devices running at full gigabit. It doesn't allow any device to get 2 gigabits for a single device. So you still only get 1 gigabit, it's a speed limit, but you can get 2 devices at 1 gigabit at the same time without bottlenecking each other, which if you are transferring files between a couple of computers, you could easily hit that. And so I feel like having a LAGG is helpful, because if you have one computer transferring files and you have some other network activity, it might not be saturating your network. I feel like it would help alleviate a little bit of those bottlenecks, and it will allow you, if you're transferring 1 gigabit across networks, it will still allow you to have a little extra overhead, even if you're not maxing out both 1 gigabit streams. I think it can still help a little bit, alleviate a little bit of bottlenecks. That way, one device isn't hogging up all your network. What we're going to do is go on a LAGG. We're going to go to the LAGG page, and we're going to create a new LAGG. So we have to create, if you're going to create bridges, LAGGs, and VLANs and those sorts of interfaces, we got to do those first before you can assign them. So just keep that in mind, because you have to create, you're basically creating different logical networks on top of physical networks. So you'll see, because for a LAGG, you'll see that you'll be able to pick IGB2 and IGB3 because they're not currently assigned to anything. So you're allowed to create a LAGG with them. You can't create a LAGG with anything that's already assigned because it's already been used. So we'll just pick these two networks. And then for the protocol, we're going to pick LACP. And there's different options. If you just want like a simple failover or load balance between them, those are simple protocols. LACP are supported by networks, managed network switches pretty well. I like LACP because it automatically, will balance the load and stuff for you, which is nice. The hash layers, you want to pick at least level 2 and 3 for your hash layers, because that gives you allows you to mix or balance the traffic between your interfaces a lot better. You could do all four, because then that gives you even more. If you do all three, options, and you level 2, 3, and 4, it'll use all those things to help balance the load out. And this is optimal if you do L2, 3, and 4. At first, I didn't know if I could select L4 if my network switch only supports L2 and 3, but it doesn't really matter what the network switch side says as much, I've noticed, because I just did L2 or L3 one time, and even though I had on the switch, I had L2 and 3 both enabled, but because I only had one enabled in OPNsense, I was playing around, it actually didn't balance that very well at all, even though the switch says it should balance better. But when I put L2 and 3 on OPNsense, it balanced out way better, so traffic was being split up a lot more evenly. So that's all you got to do. You just have to you can put a description in there if you want, which let's go ahead and do that. Actually, let's go put it. I forgot to do that. We'll just call it a LAGG. Isn't that original? Because of this description, I think is going to show up when we go to assign interfaces, so it's important to put a description in. I'm going to assign the VLANs next, because I want to get all these interfaces assigned before we configure each interface. So once we have all those assigned, we can just click through each interface and we'll just configure each of those interfaces. That's kind of how I did it in my guide, I think. Kind of walking through each part of those, getting everything set up first before actually assigning them, so we can actually do this part. And this is where I need to click on one. See, device is like, you can leave this empty and it'll automatically generate a name, so you don't really need to put anything in there. It used to be back a long time ago, they didn't even have this option here, but now they change how the interface names are generated. So they actually give you a way to actually control that a little bit, instead of just leaving it at the default. But we'll just do the default. The parent interface is going to be for all the VLANs. Notice you can actually still select IGB2 or 3, but we're doing a LAGG now. So we're going to do VLANs are going to sit on top of the LAGG. That way, all the traffic that goes across VLANs will go to that logical interface that's the LAGG, so we can distribute the traffic. We don't want to use IGB2 or 3 for the VLANs, because we actually want it to be on the LAGG. So for all these, we're going to pick LAGG, and we're going to pick VLAN tag. We're going to do 10, and we're going to do this one, DMZ. There's VLAN priorities you can set. I'm just going to leave best effort for all these. You could, if you're doing like a voice over IP network or something, you can pick video, or you're doing like streaming video that you want to make sure it gets more priority. I'm not sure how much that actually affects. It's kind of like quality control services, but I'm not sure how much it actually affects performance between networks. That would be interesting to actually test that out to see what happens, but you'd really have to stress test that to see how well that actually does does performance wise. So this we're going to create our DMZ network of VLAN 10. So I'm just going to go through these real quick, because it's just going to be the same thing. Okay, we're just going to repeat. Of course, we're going to LAGG. It's not the bottom anymore, so we're going to repeat all these. And this step is just, you're just creating all the VLANs. We're giving them different VLAN tags. I like to make my VLAN tags kind of similar to the IP address, because I'll do like 192.168.20. To match the VLAN tag. Makes it easier. You don't have to do it that way. That's usually what I like to prefer, because it's easy for me to tell what the VLAN number is. So we're going to do 30. I'm trying to make this match my guide that I did online. This will be the IoT network. I'm just creating a couple sample networks to show what you can do. You don't have to create these. You can create less of these. You can create more of these. I actually do more of my own network than these. Might seem like overkill, but I actually like separating things by logical function, or by functional domains is what I like to call it, or whatever. So that even if there's only a couple devices in there, I'm not doing it because I'm worried about too much broadcast on one network and stuff like that necessarily. I just like to have them separated, because it allows me to group devices together and apply the same firewall rules to those group of devices. So it's a nice way for me to group and contain and do firewall rules in every type of group that I want controlled a certain way. And usually if I put all my IP cameras on one network and I put all my IoT devices on one network, and there's patterns that kind of emerge that of how I want to allow access between the networks. So thinking about where you want to put your devices and how you want to separate them really helps you formulate how you want to set up your VLANs for your networks. I think it's very important to be able to think about that, how you're going to do that. So here is a LAGG, and we're going to do 40. This will be our guest network. So the reason I have several networks that I'm creating is mostly to show different examples of how you can use different networks. And I try to create different firewall rules for the different networks so that I can actually show you like a little bit like, okay, what some of the reasoning is behind some of these networks that we're doing. And because I just did 5 VLANs just to show you some examples here. And this one's IPCAM. Save. Okay. We're going to apply this. And now when we go to assignments, we'll be able to see VLAN 1 through 5 right here. So we're just going to assign this, and we're going to use the same description that we used for the VLAN tag, just and as our interface name, because that way they're all the same. It keeps it consistent. There's that, and it's automatically going to be selecting these, it looks like. So VLAN, oh, you know what? I just realized I need to change something. That's why I hesitated. IoT. This is what happens when it gets late. I actually messed up something when I was demonstrating something. But hey, we're doing this on the fly, right? We're doing IPCAM. Oops. Okay. All we're going to have is we have our WAN and we have our LAN for our management interface, and we have our 5 VLANs set up, and we can just click save. Okay. And now that we have this set up, we can go through each interface and see what we need configured here. I want to start with the WAN, but there shouldn't be anything you really need to configure here unless your ISP uses something different than DHCP. So by default, we should be able to leave DHCP. Oh, yeah, the only thing we do need to change, I forgot, for IPv6, we need to change the prefix delegation size. This is highly dependent on what your ISP gives you. It will probably be, for residential ISPs, it'll probably be 56 or 60. I'm going to pick 60 because I know that works with Comcast Xfinity internet. Not sure if they give you 56 unless you're a business. I'm not sure. So this is your prefix delegation. And then you can say send IPv6 prefix hint. I think that's usually recommended if, to try to kind of say, hey, I want this, kind of forces you, or kind of like gives a stronger indication, I want this prefix size. So those are the only things you really need to change on the WAN is your prefix delegation. That's important if you want to have multiple networks with IPv6 on it. If you only have one network, which is the flat network, which is a real basic network, you could do it that way. You can leave it at the default if you're doing that. But we're going to make a more advanced, sophisticated network, right? So we're going to have IPv6 on all the networks. So we're going to apply those changes. Let's go to the LAN. That's what we're going to do next. This is our management interface. And you'll notice it already has static IPv4 and it has track interface. This is what we want for IPv6 if you have dynamic IPv6, which is probably a lot of people. I wish it was static, but it's not for a lot of us. So if you do track interface, luckily the LAN is already set how I'd probably want to set it. So you just we're going to track the WAN interface. And because we have the prefix delegation of 60, your first 64 bits is your network portion of the address. Because we only did 60 bits out of 64, we have 4 bits, which means we can have 16 networks that we can work with. So that means we can have a prefix ID starting with 0, which we have here, going all the way to 15, 0 to 15, but it starts getting, this is hexadecimal, this prefix ID, so it'll go 0 through 9, and then when you get to 10, it'll be A, and then 11 will be B, 12 will be C, and then it goes all the way to 15, which is F, right? So So you can go 0 through F, basically. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That'll be all of your prefix IDs that you have available if you don't /60 or, your prefix delegation is 60. You will have 256 networks if you have, /56, right? You can have a lot of networks. A lot more, I should say. So this is what we'll do here. We actually don't need to change anything for the LAN because it's set by default. I just wanted to show you what it looks like. Now for the other networks, because we created them, these are new networks that we created, not out of the box. So we always have to, we're going to have to enable and prevent interface removal, so you can't actually delete them without unchecking this box. We're going to say static IPv4, and then we're going to do the same thing here. Track interface, Okay, IPv4. So we're going to do 192, 168. Move the mouse so you can see, and we're going to do 10. This is where we're going to do .10 for our network, and then this is static IPv4. You want your interfaces usually to be .1, and then you want to make sure it's /24 because that means you can have 255, 256 total addresses under that network, but 0.1 that takes one. The .1 it takes an address, and you can't use .255. So really, you have 254 addresses that you can use in that network, and not 256. So, and then we're going to do track interface, and for this one, we're going to use 1, prefix ID 1. We're just going to increment each one, okay? And then we're going to do allow manual adjustments of DHCPv6 router advertisements. So after doing this, I realized I probably do need to change something to the LAN. I thought out of the box it's good. I forgot to mention. I'll mention it when I get to the LAN page. And I clicked apply. Even I said I don't really need to save time, because it does take us a few seconds, to apply these changes. This part of applying changes is actually a lot quicker when you have a little bit faster system. This is not a slow system, but it's slower than like my VP2420, which doesn't take nearly this long. And I feel like it depends what changes you're making if it takes longer. Okay, let's go back to the LAN. I messed up. Yeah. But that's what I'm winging it, right? So go to prevent interface removal, just so it just makes it where you can't accidentally delete it. And I forgot, for IPv6, I like to allow manual adjustments to DHCPv6 router and advertisements. So this allows you to make some additional tweaks. We're going to not hit that just yet, because you'll see every page has this, right? We didn't change anything. So DMZ is our first network, our VLAN, our user is our second one. So we're going to user network. So click on user, we'll go to enable, prevent, and then IPv4, track interface. Okay. And then it opens up these menus down here. This part is just going to be a little bit repetitive, right? Some of these configuration options. I really fumbled my keyboard there. Okay. Really bad. Okay. And then we'll pick 24. This part's the same, so I'm just kind of mumbling a little bit. We're going to pick 2. Make sure we hit OK. Save. You do have to make sure you hit save. We don't have to hit apply yet until we're done, but you do have to hit save. The third network is IoT. I'm just going in order just so I can keep it straight here, right? Click these 2 options. IPv4, static IPv4, track interface, and 192.168.30. This one's going to be 30.1, right? You see the pattern that we're doing here? 24. And this will be 3, right? 33 kind of goes together, right? Helps keep the networks nice and organized. And then the fourth network, we got 2 more to go. Just bear with me. You guys wanted a video of this, and it's going to take a lot longer than a written guide. I apologize. I'm probably going to have to split this video up into pieces. I was going to do all the OPNsense configuration in one video, but I might actually do it in 2 or 3 videos, right? I don't know. Static IPv4, track interface, because I want to be able to explain it a little bit, not just, you know, do it really fast. Some people just do really fast videos. Oops, I don't want to do that. Do really fast videos and try to skim over stuff really fast. I want to make sure you guys understand this, because I know it'd be helpful, because I wish I had detailed information when I was doing this. First starting out, I just had to kind of learn, read, play around. I already had a little bit of networking background, which helped, because I did have a CCNA, Cisco CCNA back in the day. I got it back in the year 2000. That tells you how old I am. Back in the year 2000. I just sound so old when I say that. Man, I just sound so old. Why'd I have to be so old? I got it fresh out of high school. So I was in high school, year 2000. I graduated. So if that tells you how old I am, right? Okay, this one's going to be 50, because this is our 5th network. Make sure we're on /24. If you only put /32, that means one IP address, so you can't have any networks underneath it. It's just one interface. So that would be a useless network. You got to make sure it's /24. And this will be 5, right? All right, finally, we made it through our interface. And now we can hit apply to all of our interfaces changes. Okay. Now we wait for this. Next up will be setting up DHCP. Because by default, DHCP is only set up on the LAN and WAN interface. But now we need to set it up for all the VLANs as well. Because every network should have a little bit of a DHCP range in general, unless you, for some reason, want to assign IP addresses for every device in that network. Which, yeah, depending on what it is, maybe if it's IP cameras, maybe you want to do that. I don't know. But I'm going to show you how to do it for each network as soon as this loads. Wait, maybe I didn't click it. Sorry. Oh, there it went. Okay. Maybe I didn't do it. I don't know. I was just sitting there waiting, just talking away, and I didn't realize I must not have clicked it or clicked too soon or something. Okay, so what we're going to do now, we're going to go down to Services menu, and we're going to go to DHCP4, and we're going to start with the LAN. We're just going to look at the LAN. See how it starts with 100, it goes to 199. And I think, I had to cut out there real quick on the video, because I wanted to check what I actually had in my guide so that I'm consistent. But by default, it does 100 to 199. I just did 100 to 200. It's not, that one extra IP is not going to be that big a deal, but I just want to make them all the same and consistent with my guide that I wrote. You can pick smaller range. You probably don't have 100 devices. I don't know. If you do, if you have more, you can pick more. I'm just going to make them all 100 to 200. Just keep it nice and clean, consistent. But that's all I'm going to do for each of these networks, right? So I'm going to start with, I just go all the way down. I'll start with DMZ. You can do this. You can just copy this and then paste, right? And so that way you can just do this and then 200. So it's just kind of the same kind of boring thing here, I guess. We'll just do this. But this should be a little bit quicker. Copy this so I don't have to type as much. 100. We're just doing 100 to 200 on each one of these. And so this is when you plug a device into your network or connect through wireless. That's what IP addresses you're going to get, right? So you're going to get one in that range. And then if you're going to manually assign static IPs, you should pick it outside that range. Some devices or some firewalls or routers or whatever will let you pick a device within your range and be fine with it. But OPNsense likes to have it outside. Might even give you, a fit about it if you don't. Let's see. Here we go. Maybe I should just speed up these parts where I'm doing this. I just continue with the rest. Boop, 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 boop. Yep, it'd be easy, huh? Here we go. We're on the last one. Final stretch. Maybe that's what I'll do, I think. All right. I just realized I messed up again. I just messed up again, so I forgot to enable it. We got to enable all these. Man, okay. It's getting really late, and so this is probably the worst time for me to do this because you got to stay focused. Because I'm trying to narrate this and click on all these settings, but at least I caught it, and I didn't have to like go back and redo the video. I'm just going to roll with this. I'll just show you that I'm just going to enable each of these and go all the way down, right? And let's see, LAN is already enabled, user, right? And okay. Okay. There we go. Now we have that enabled. Now we can go to DHCPv6 for IPv6. All right. Okay, so for IPv6, the interesting thing is you actually can't assign DHCPv6 because it says there's no available range configured because we're not plugged into the network. Everything is all dynamic for IPv6 the way we have it configured right now. So you can't even enable IPv6 yet until you're actually getting a DHCP IPv6 range, address range. So what you normally would do is enable just like IPv4, and we're just going to do 1000 to 2000. And the way to do that to IPv6 is you do 2 dots, and then you could type that. So you're just assigning the last few bits or whatever of that IPv6 address to be 1000 to 2000, and it'll take whatever dynamic part of that portion of that IPv6 address, and then it'll fill in a little bit of zeros, and then it'll have 1000, 2000. So it keeps your addresses pretty simple. So we can't actually save this, but you would just do that for each of these interfaces. Once we're connected to the network, I might maybe show that when we circle back around because I want to be able to show, I guess I could probably show this. Like, so after you configure that part, you would go to router advertisements and you click on DMZ and whatever interface, guest, IoT, and then you could say, I like to pick assisted because if you look at the description here, it says it'll use, assisted actually uses stateful DHCPv6 and Slack. So I think it'll try to use DHCPv6. Not all devices support that. It seems like, which I've read about, maybe even some older Android devices and stuff like that. So it's kind of interesting that not all devices support that. So, but almost all the devices that don't support that would support Slack. Sometimes that's the only way you can get an IPv6 address assigned is to via Slack. So I like to do assisted because that way, either way, you can hopefully get an IPv6 address. Because I noticed that sometimes devices wouldn't get it if you don't do Slack. So I'm going to hit save and see if that works. But I think, so we can actually do this part of it. We can actually just say assisted on all these. Oops, hit the wrong one. Assisted. So we actually will save these and we'll at least have this part of it done. We just can't do that one part until we're connected to a real network. Because we're connected to any network, I should say, because we're not actually connected to anything right now. Assisted. Assisted. All right. Okay. One thing that I want to show is once you have DHCP enabled, you can actually start plugging devices in and actually will start working as far as connecting your network together. One thing I like to show is actually Unbound DNS. So if we go to Unbound DNS, we can go in here and look at some of these settings here real quick. By default, it listens to every interface. This is mostly probably what you want. I like to enable register DHCP leases so that when you have any device that gets an automatic IP address and has a host name associated to it, it will register that so you can use that host name when you when you refer to devices on your network. The same thing with DHCP static mapping is you can register those DHCP static leases as well. So I like to enable both of those options so that I like typing host names in on my network instead of IP addresses all the time. I think that's a very handy way of doing things. So one other thing that you might want to do is maybe, I don't think it hurts performance. It might slow down queries a little bit, but I like to flush the DNS cache during reload, because if I'm making DNS type changes, hostname changes, and stuff like that, I have problems with it hanging on to the old IP address unless I sit there and flush the cache of, on OPNsense and flush it on my device itself, because everything wants to cache DNS, right? So it's good to be able to flush that stuff out sometimes, because they do it for performance. But if I'm making a change to a host name or IP address or something, I'm moving stuff to different networks, sometimes I need that stuff to get flushed out. One thing that I wanted to mention is if you temporarily want to connect this box to your existing network, so you can do updates and those sorts of things, I'll go ahead and mention it here. But if you go to query forwarding and you can click on use system name servers, because we have in the system name servers that I showed you earlier, it's set to DHCP override the name servers with DHCP. Whatever, since we're not plugged into the network, we're not going to see anything here. But if you're plugged into your network, you'll see like a local IP address, or if you're plugged to your ISP modem, you'd see a ISP address or a DNS server there. But if you're behind another router, I've noticed if you use the system name servers and do DNS query forwarding, it seems to work a little bit better, because I've had some weird things happen on DNS because I'm behind my network, and if I'm doing all my DNS stuff that I normally do on my main router, if I have another router behind it, I usually just forward the queries to my other router because it seems like DNS works better that way. So you might want to check this option temporarily if you're working behind your other router, because otherwise you might have problems trying to like download updates and stuff because DNS isn't going to work right maybe for you. Then when we're done, you can uncheck that. When you make that your main router, you can uncheck some of these options, and we can go in and configure like DNS over TLS and those sorts of things. But I'm going to come back around to those issues there. Okay, now that we've finished looking at some of the basic settings of Unbound DNS, I'm going to create a couple of DHCP static reservations for static IP addresses for a few of example devices on this network, because we're getting ready to create firewall rules. I'm going to create firewall rules for each VLAN that applies to the entire network, but I'm also going to create a couple example rules for specific devices within each network, because it's better to have as fine-grained control, firewall rules as possible to limit access as much as possible. So a good approach is to have network-wide rules that applies to everything, which are a little bit broader and a little more general rules. It's just a catch-all for every device to isolate various portions of your network. But it's also very handy to be able to, and more restrictive and more secure, right, to actually do it between individual devices if you just need to access. If you want your whole network to access a specific machine, or you want a specific machine to access another specific machine, it's good to have those fine-grained controls. And static IP addresses, I feel like, make it a little more reliable between the networks, because you can create firewall aliases that actually have dynamic host names that have dynamic IPs. But I found that to be unreliable at one point in time when I tried this a while ago. Maybe it was a bug they fixed. But whenever I use dynamic host names that have dynamic IPs, it would lose the IP address sometimes, and so then the name wouldn't resolve anymore, and so the rule would not block access or allow access like it should, and so I didn't find that very reliable. So I started making DHCP static reservations, and then creating an alias that points to that same host name, which has a fixed IP address, and that seems to be much more reliable. So that's what we're going to do next. So as you can see, I'm going to click over here. We're going to go to DHCPv4. I'm only going to do static IPs for IPv4. You can do it for IPv6 if you want as well. The process is pretty similar, but I'm focusing on IPv4 as I did in my guide. So we're going to create a static IP reservation on each network. You can go to this leases page under DHCPv4 and you can see all the devices that have leases here. And this is kind of a quick, nice way of adding a static, mapping for an IP address, for a MAC address. I mean, straight from this page, which is nice because you don't have to type in this MAC address if you use this page. So once you're on the DMZ interface page, at the bottom, you can create DHCP static mappings. If you create it from here instead of from the leases page, you are going to have to manually type in the MAC address. And so I am going to do that real quick. And it's not very fun. I was going to try copy and paste, but since I'm using the screen capture program, I forgot I can't do that. So anyway, we'll just type it in real quick. So we're just going to make this 192.168.10.10. Notice that I'm using .10 instead of anything within .100 to .200 because that's our dynamic IP addresses. We want to be less than that. So I'm just choosing this, and we're just going to pretend we have a web server in our DMZ network, which is a plausible scenario. And so we'll just hit save, right? And then you'll notice down here, we can hit apply changes, but we can, just like on the interface pages, we can actually do this later, but I'll just go ahead and click it because it's pretty quick here. So you'll see down here at the bottom, we have our DHCP static mapping, and we're going to do this for each interface. I actually have for the guest network. Actually, I don't own my guide. I'm going to follow my guide. So I'm going to go to the user network, sorry. And we're going to click at the bottom because I actually didn't create a device for each network because, it's just the guide was already getting really long anyway, right? So we're going to do this MAC address. It doesent really matter. I'm just kind of following it real quick. It doesn't have to be exactly the same, but I'm just going to make it consistent. 192.168, 20.10, and then this was going to be our PC in our user network. Next, we're going to have IoT for all your IoT devices. So we're going to go to the bottom. I'm getting distracted here. I gotta focus, right? Focus. Just like I mentioned earlier, it's late at night, and I'm recording this on multiple nights, so that makes it this makes for long recording sessions. All right, so this one's I'm kind of following the guide just so you can see where I'm coming from. If you are following the written guide as well, you can see me actually doing what I wrote about on video. Have it documented on video here. So this one's going to be 30.10, and this is going to be our printer. So now we're finally on the final one. I'm doing the IPCAM network. I actually have three devices I'm set up here. I'm going to pretend I have 3 cameras, just as an example. 4 4. All right, so IP address. So these ones I'm going to make these ones sequential because I kind of wanted to show a firewall rule with how you can have sequential. I forgot 168. You can actually have sequential ranges in your firewall rules, which is pretty cool. A host name. Actually, put our host name in. I'm just going to call IPCAM1. Okay. And we'll wait to apply changes because I'm going to add 2 more here. Sorry, this part's slow, but I'm just kind of showing you real quick. I actually used a website to generate random MAC addresses so they look, legit. It's getting late. I'm just losing my mind here, guys. Okay, I'm doing this for you. I'm doing this for you, really. Okay, doing it for you. So I hope you like it. So 2, 3. 8.50.12 on IPCAM 3. All right, IPCAM 3 coming up. Yeah, now I'm going to apply changes there. Okay. Now we're actually able to get to the point where we can create firewall rule aliases. Aliases are really nice because it allows you to make your rules a little more repeatable or readable. readable. It makes them easier to maintain as well, which is very handy. I'm actually scrolling down to on my guide here to make sure that I'm matching what I'm writing here. Okay, so let's go to firewall section, the menu, and then we're going to go to aliases page. And you'll see, normally you have 7 shown by default, but I changed it to 20 so we can see all of our aliases. These aliases that are on here are all the ones that are created out of the box because we never created any yet, right? So notice you'll have some, we got the bogons, those are filtered on the WAN IP address side, and these get refreshed periodically, I think monthly by default. And then, so, down here at the bottom, you'll see various network aliases created by default. And you'll see what these descriptions are. When you go to create firewall rules and you see WAN net, LAN net, and all, you'll see these in there whenever you go to create rules. You'll also see WAN address and LAN address, and one for each interface. The address ones actually don't show up in here, only the network ones, which is kind of interesting to me. I found that to be kind of interesting, but we're going to make use of these actually as we create some of our firewall rules, especially if you're using IPv6. You don't really need to do it if you're not doing IPv6 necessarily, unless you really want to, and I'll explain why in a minute. So what we're going to do is the first one, alias we're going to create, if we click add button down here, is we're going to call it private networks. We're going to use this rule to help isolate all of our networks because we're going to block anything that's a private network on each interface for each network. So when I say interfaces and networks are kind of interchangeable, and then you talk about it from a firewall perspective. So you'll see it even in the interface on OPNsense, in the web interface, I should say, not the interface. So in the web interface, you'll see the terminology a lot of times will say interfaces, but each interface can have a whole entire network off of it. That's why we do like /24 off the interface instead of /32, because /32 is a single IPv4 device address, and if you do /24, that's a whole network with, as we mentioned, 254 usable addresses, because you have to subtract the 2 off there because one's used by interface and one is a broadcast. The 255.255 is a broadcast address. So we're going to create private networks alias. So we'll need to select networks. So what we're going to, if you're only using IPv4 in your network, I'm showing IPv6 as well because a lot of people are interested in it as well. But I'm keeping it kind of basic because I don't use it fully in my own network, because I've had issues trying to get IP addresses, and certain things will default to IPv6, and if things aren't set up exactly right, you'll have issues. So if you're only using IPv4, you can actually use the RFC 1918 private IP address ranges, which is 10.0.0.0/8, and if you hit comma, it'll I hit it, sorry, I typed it in the wrong box. 10.0.0, don't type it in the categories box like I did, so type it in the content box. If you do /8 and then hit comma, it'll group it in a little box there, and then 172.16.0.0/12, right? You can look up what these ranges are online as well. They're not a secret. So 192.168.0.0/16, right? And I would say comma just to get that box to show up. Okay, so excellent. Type an extra character, but anyway. So these are your private IP addresses for IPv4. This will block everything, all your existing networks. You can use it to block all your existing networks from each other. The nice thing about doing it this way for IPv4 is if you add a new network, a new VLAN in the future, you don't have to remember to add it to this alias every time. So it's less maintenance. But because we're doing it, this way, we'll account for this in the rules. I'll show you later. But because we're doing IPv6, I'm going to take this out, and because we're doing dynamic IPv6 actually. Because if we're doing static IPv6, you can actually type in your full IP. You would have your IPv6 range. It would be, whatever it is. Let's say it's 2001.653. Yeah, I'm just making up one. Okay, so let's say what is this first half of the network address? I'm just typing in random address. And so if you're doing a static IPv6, you could do something like this, especially if you had /60, let's say. You could actually do this along with your IPv4 addresses that we just typed in, and that would block everything IPv4 and IPv6 of all that you would consider your private networks. Even though IPv6 is publicly addressable, but this will be one way we're just going to use this alias to isolate our network. So that's the whole purpose of what we're doing here. It might be a little bit confusing, but I'll try to explain it as we go along. But you'll just need this. Just remember how we want to do this alias. So you can do it two ways, but I'm going to show you the way I'm going to do it in this guide, because it should work for IPv4 and IPv6 if you have dynamic IPv6. It could work for static as well, but if you have static, you can just type it directly in like I just showed you. So someone showed me that in my original guide, I actually did this a longer way, but you can actually type _ and bring up those aliases that are already created. And notice we have one for each network, so we actually can say LAN, right? And then we'll do _ option 2. They're going to be called different depending on how you added your interfaces. Option 3. So we're going to add each of these networks in here and just to add them all of them except the WAN, of course. All these optional interfaces. These represent your VLAN networks. So if we add all of these to our network, this will be our private, IP network ranges. So this will be what we describe in our description here. So this will be what we use to block and isolate our networks. So I want to show you. You can see what's inside of these aliases as we go through here. If you go to diagnostics, let's just jump to there real quick and click aliases, and then you can actually go up to your option. Let's pick optional network 2. You can see this is our DMZ network. It has the IPv4 address. Whenever you're plugged into the network and you actually have IPv6 addresses assigned, you will get that network address for IPv6 in there automatically. So we get IPv4 and v6 in this. So you can use this alias for both IPv4 and IPv6 to isolate your networks. So that's a little trick that I learned from someone that said you can do the underscores, because I noticed you couldn't pick I was trying to enter WAN.net or LAN.net, and that doesn't work. I'm like, oh, it's underscore, and you have to use those aliases. So I was doing some other way. It was a little more complicated. So now that we have that one created, we're going to actually go and create one alias. Let's get back to our aliases page up here. We're going to create one alias for each system. And so these will just be hosts, okay, that we're going to create. Because we're just going on this so we can refer to them in the firewall rules, so we don't have to type out the IP addresses. If we change the IP address, we want to move it to a different network, all we have to do is just change it in this alias. So it minimizes the places you have to edit. We're going to call this web server. And yeah, we assigned this to 10, if you remember, right? Local web server. Okay, we have our monthly description. All right, so the next one we're going to have a PC. I might speed this section up, so yeah, just make it a little quicker. Yeah, let's do this too. What do printer? Okay, for the IPCAMs, cameras, we can actually, the cool thing about this one is we don't need to create one alias for each camera because I made the IP addresses close to each other on purpose. The cool thing is you can actually add a range in here. You can say 192.168.50.12 or .10, I mean, to, and you can see I put a hyphen in there, 192.168.50.12. I'll make sure I type this right. And you see if I click off of it, it actually puts it in a box like that, and I'm gonna say IP security cameras, right? So that's pretty cool. So you can actually see the content here. It actually put that network range in there. I somehow I accidentally typed this in the wrong box. So I want to fix my mistake. I typed it in the wrong box. It gets me every time if I'm not really paying attention because I'm assuming it's just going to be that first box, but it's not. It's not the first box. This is IoT network. Make sure I get it right. Now that we have our aliases, we're going to create some rules. This is where some people might get confused about some things. So I'm going to go to the floating rules. Floating rules can actually apply to all interfaces, which is pretty neat. So it's not tied to a specific interface. That's why they call them floating rules, because you can just kind of assign them to whichever interfaces you want. By default, a floating rule will apply to all interfaces, but you can pick any set of interfaces that you want for floating rules, which is kind of interesting. It might get a little bit confusing which ones get applied to, but OPNsense actually recently added it on the pages where the firewall rules are for each interface. They actually showed the floating rules and firewall groups and anything that gets applied before the interface, which is really cool. I'm glad they added that because that allows you to see what other rules are coming, are being applied first, because sometimes these rules that get applied first will trip you up because it's doing something before you can even get to it into the interface, and something might be happening that you don't want to be happening, right? So we're going to create one rule here. In my example, I'm only showing one rule. I actually make use of this for different reasons on my own network, but for this example, I'm only going to do it for IPv6 actually. So because IPv6 relies on ICMP much more than IPv4, and you almost always want to enable certain aspects of ICMP. You can get real granular which ones you want to apply, but to make it easy, I'm just going to allow all ICMP, because some people see it as a security risk, but IPv6 is the ICMP is a little bit different how it's designed, and it really helps make the network function a lot better. So and if you do like online tests for networks, your online tests for IPv6, you're going to get a lot better scores if you allow ICMP. They're going to get dings for that, and because it allows for discovering stuff. You're still protected by your firewall. I don't know what the exploits are for this scenario, but I haven't heard of too many things, so I feel like it should be pretty safe. It'd be better if you get more granular with it, but we're just going to do all ICMP. Might make you feel a little uncomfortable, but you have to allow at least allow it to the WAN interface, even if you don't allow it to your whole network. So we're going to pick the TCP/IP version of IPv6, and then we're going to go to we're going to pick the protocol. We're going to pick ICMP, and then we're going to say source is any and destinations any. Description, I recommend say allow ICMPv6 on all networks. We're going to start with the LAN network, and you'll notice there's two allow all rules here, so you can actually get to every network from the LAN. Some people like to do that with their management network to allow access everywhere, but I like to restrict it a little bit more, even from the management network, because if you get something in there, that's the worst, the most sensitive network for something to get bad to get into, but at least your other networks will still be protected if you only allow access that you need to allow access to. So what I'm going to do is we can actually just delete these, but we're not going to apply changes because we'll lose access. Well, we have a anti-lockout rule, so you shouldn't get locked out of the web interface. But we're just going to go ahead and delete these, okay? But we're not going to apply changes, so we don't have to worry about. Even though we have an anti-lockout rule, we won't worry about getting locked out here. So I'm going to clear this out so we can start fresh. So I'm going to create a rule. The first rule, which we're going to use our private network alias that I just created earlier, that is going to, we're going to say pass, leave it at the default, and we'll say LAN default, in default. So we're going to do IP4 plus IPv6. We can actually combine the rules together in this one. And we'll say any protocol, and the source is LAN net because we're in the LAN network. You can start typing it in to get to it. And destination, we're going to actually pick, we're going to do a destination invert. So don't forget that, this is critical. And I'll explain what that does here in a minute. We're going to do private networks as your destination. And all you have to do now is just do a description that says allow access to only the internet. Okay. So this is going to, what this rule is saying, it says anything that's coming from the LAN network, which is, this is a rule applied to the LAN network. Anything that's coming from the LAN network and going to any network that's not a private network. So it's allowing this. So one thing I forgot to mention is when I deleted all those rules out, if you have no rules on an interface, it means everything is blocked. So the only traffic that's allowed is local traffic between devices on the same network. Those devices can always communicate. It does because nothing's being routed across networks. So whenever one thing you need to keep in mind is if nothing matches any rules, if it gets all the way to the bottom of your rule list and it doesn't match any of these rules, it will be blocked. All that traffic will be blocked. So you don't have to put a rule at the bottom that blocks everything, right? It's going to happen anyway when it gets to the bottom of all your rules. So it's just going to fall out the bottom and be blocked. So basically, we're kind of doing almost like a whitelist. We're only allowing access to things we want to allow access to. But there are still cases of needing to use blocks, but I actually use passes almost more than I use blocks, because what I end up doing is I allow anything that doesn't match a pass, it's going to be blocked anyway. So I don't always use blocks a ton, actually, unless it's like an IP, malicious IPs that I want to block. In that case, you definitely want to hit block those. But for allowing access across networks, because of how these rules are constructed, you actually don't need as many maybe block rules as you might think you need. So this is actually saying when you do destination invert, it has an exclamation point here in front of the destination, which means not. So we're doing a pass rule. So it's saying allow traffic from LAN network where it's not a private network. So that means anything that is a private network will be blocked because it won't match this rule. Won't match this rule at all. So it'll fall out the bottom. So by having this one rule in here, we've blocked access to all other private networks in our network. Okay, so this rule right here will give us isolation that we want, but we still need one more rule to complement this rule, because if we just leave it at that, you're going to block your DNS and anything else that's running on your interface, like NTP, like for your network time protocol server, anything that's running off your interface. DNS is the biggest one. If you're not using NTP, your local NTP for your devices, that might not be as crucial for you. But we need to add one more rule to allow DNS, and we're going to put it before this rule. So the way we do this, you're going to need a minimum of 2 rules to have an isolated network. There's other ways you could probably do it. Like if we weren't blocking all private IP addresses, and we were only blocking the other networks that we have and not our own one that we're already in, you could get away with one rule, but you'd have to keep updating your network addresses all the time. So you could do this in one rule, but I like doing it this way because if you add new networks, it's already blocked by default. I'd rather it be blocked by default than allowed by default, because you might forget to add that network to your restrictions, and then it'll just have free access to everything. So you could open up a security hole accidentally. So that's why we don't. This is kind of why we're taking this approach. So we're going to do a pass rule here on the LAN, and we're going to do IPv4 plus IPv6 again. It's nice that we can do both with one rule. And where the protocol we're going to do is TCP UDP. DNS is supposed to be UDP. We're going to say source is LAN net, just like before. It's always better to say LAN net than any normally, because if you're in the LAN, it's a little bit more restrictive. And then destination, of course, is going to be LAN address. So this is your gateway for all your devices on your LAN network. The LAN address is your interface address, and that's your gateway to the internet and to other networks in your local network, right? So that is going to be 192.168.1.1. That's what the LAN address is. And DNS server, when you do Unbound DNS, when it's listening on all interfaces, it's going to be on every, network address like that: LAN address, DMZ address, IoT address, all those things. That's your gateway for each of your networks to have its own gateway based off your interface. That's how it gets to any other network, even your local networks. So destination port range is DNS. There are some built-in aliases here for ports, and so we can just make use of that with DNS, and then we're going to say allow access to DNS. Okay, and then when you add new rules, it's going to put it at the bottom every time. So what you can do is you can click this checkbox over here to the left of that rule, and then you can click this arrow, which means move it above this rule. So we want to make sure this order is correct, because the order is important, because it executes rules in the order that they're in this list. So we're going to say apply changes. Now this is the bare minimum rules that you'll want for most networks. I'm going to create a rule for ICMP for IPv4. This one's just kind of nice. Since your LAN network is going to be the management network, if you're following this guide, I think it's kind of nice for the management network, since we're controlling all your network infrastructure, to allow ICMP for IPv4, so you can ping other devices on your network. Some people don't like block ping completely. ICMP, which includes ping and all the trace route and all that kind of stuff. But it might be useful to actually have this enabled for your management network, so you can actually do troubleshooting on your network. So we're going to do TCP. We're only going to do IPv4, the default. We're going to do protocol ICMP, and then we're going to say LAN net. We're going to allow our devices on LAN net, and you could say. You could, if you had a specific device that you want to only use for troubleshooting, you could do that. But we'll just allow the whole network because it's our management network, right? And destination is any. So, and then we're just going to say allow. It's good to have good descriptions, all right? So you know what this is for. Allow ICMP-v4 from LAN to all networks. Of course, I didn't hit the space bar here. We'll make it pretty, make it readable. Okay. Well, and then we got to, just like the last one, we're going to move it above the bottom rule. So we're going to put it in the middle here. You can actually put this at the top. It'll be fine if you had it at the top. No big deal. No big deal. So we're done with the LAN network. Okay, now we just need to create rules for our other interfaces. What we can actually do I didn't mention this in my guide, but to make this quicker for the subsequent interfaces, we can actually clone. If you notice this button here, we can clone these rules because they're going to be similar for each network. We're going to, most of these networks are going to have at least these 2 rules, and so we're going to actually clone them. So I'll show you how this works because this saves a lot of time. I do this a lot when there's rules that are similar across networks. I try to minimize duplication across interfaces, but some of these rules to isolate the networks have to be done, on each network. And some of the stuff you do have to kind of duplicate and just tweak them a little bit. Or if you have a rule that's really similar to what you want to do, but not exactly the same, you can use it to give you a head start on it, so you don't have to type everything all over again. So we're actually going to make use of that when we go to the DMZ network. Will be the next. So I'm going to start with my LAN network because it's the one that we just finished, and we'll start with the bottom one here. We'll just clone this one. And so since we're going to move it to we're going to clone it to the DMZ network. So we just type in DMZ. We got to make sure, it's important that you make sure this is on the proper interface, which is DMZ. And then we're going to change LAN net to DMZ net. Right? Everything else is the same. Private networks, we're still blocking that. Allow access to internet, we can still use the same description, right? So the cool thing is it'll jump you over. See how it jumped us over to the DMZ network. So now we could just say allow access to internet only, which is cool. And we'll supply the rules at the end, just because it save us some time. So now we go back to here. We're just going to do the same thing. DNS. We're going to change it to DMZ. So this will save us a lot of time here. That's why you got to make use of these features. So we're going to do DMZ net. And then we got to do DMZ address. So we got to make sure we change both of these to get the DNS allow rule correct. And you notice if we start from the bottom when we clone the rules and work our way up to the top, it will actually put them in the right order. So from my guide that I did, that's all we're going to do for the DMZ, because we want it to just be isolated. It only has access to the internet. We don't want anything, have it access anything on our network, because that's the DMZ is intended to be its own isolated network from the rest of your network that the public can access. Hopefully you have other security stuff in place in front of that as well. You can use Cloudflare or whatever else, tunnels and stuff like that, or whatever. So we're going to go to the user network. We can actually start from this network if we want. Let's go ahead and apply changes. We'll start from this network. We'll do the bottom, and we're just going to do the same process again, right? We're going to go to user, and we're going to go to user. User net. So here we go. And we're going to clone the DNS. User. And user. Okay. Okay. Now in the user network, we actually are going to allow some access between from our PC that we have. We're going to allow the PC or any devices on the user network, could be PCs, laptops, whatever. We're going to allow this network to access our web server, which is on the DMZ, and also our printer, which is on the IoT network. So you'll get to see how this kind of access works. So we're going to create a new rule, and we're going to pick IPv4 because we're only using IPv4 right now. Protocol, we're going to use TCP. I'm just kind of referring to my list over here, so I don't try not to mess this up, right? And we're going to say the source is usernet. Destination is going to be our web server alias that we created. This is why we created aliases, so we don't have to type IP addresses anymore. It makes it real descriptive because you can see our destination is a web server. You don't have to remember what's 192.168.10.10, right? And then the port, we're going to say it's HTTPS, and it'll automatically fill in the other 2 port, which is nice. And we're going to say allow access to web server. Okay. And it's actually going to put it at the bottom like we said before, right? And then we'll move it to the middle, right? It could be at the very top, but I like to put the DNS, the ones that access the gateways first. And then I usually put like any access between networks between my devices. I usually sandwich them somewhere in the middle. I don't really have any order necessarily in the middle because it doesn't really matter for this type of specific access. So let's do one more. One more to add. We're going to do this one. We're going to do TCP, UDP because the printer, you can allow specific ports in the printer, but I mentioned in my guide that I'm just going to allow all ports because for scanners, if you have like an all-in-one printer, you have scanners and printers and stuff, it uses multiple ports. You could figure out which ports those are. I think I tried doing it at one point in time with my printer, and because there's different discovery protocol, there's different ports I was having issues figuring out which ones I got tired of. I was like, let's allow any because I just need access to the printer. One day maybe I'll tighten that up a little bit, but so we're going to say destination any. No, destination's printer. Sorry, it's the port that's any. So we say we have our printer alias and our destination port. We're going to say all ports, and we want to go down here to description and say allow access to printer. And we want to move it up as well, right? So that should look similar to what I have in my guide. Okay, now let's move on to IoT. So we're going to clone our rules, right, to get started. IoT. Okay. It doesn't matter which network we click on. And I want to click on clone IoT IoT address. Okay. Okay, for the IoT network, we're going to allow access to the web server. We have some devices and maybe we have some apps or services on there. We're going to allow protocol TCP, and we're going to allow destination web server. I like that you can just type in the alias and that brings it up. And we're going to HTTPS. Allow access to web server. Okay. One trick is I forgot you can multi-select rules, so we'll actually do this at the end. I'll show you how to do this, so it'll be a little bit quicker. So we're going to add the IP camera feeds, and so we're going to allow protocol TCP, and it depends on what kind of video feed you're dealing with, but you might need UDP. But if you're using RTSP, I think you can use TCP. That's what we're going to do in this example. So source is IoT network. We're going to allow our IoT network to access the camera feeds. Let's say the reason being, let's say we have a monitor, a camera monitor or something. We can allow specific access, even though it's better to have it completely isolated if you want, but this allows us to have some monitors, we can have use our phones or whatever to access the camera feeds. So the source is going to be, wait, what am I doing here? Sorry, it's getting late. Destination, IP cameras. I keep saying that, sorry. Okay, IP cameras are destination, and we're going to use port 554. You could create an alias for this port if you want, which is what I did do, so I can make it descriptive. But we're going to say 554 is to 554. That is RTSP. That's what a lot of cameras uses. Real-time streaming protocol. Allow access to this is delay IP camera feeds. Okay, camera feeds, and then we just need one more. We're going to allow access to printers so we can print from our phone. Let's say, for example, we'll say IoT. We'll do protocol. We'll do TCP UDP, and then we'll do source IoT net. And destination, we'll do printer. So this shows you some examples like how you want to allow access between your networks. You still keep things isolated and you allow access where you need it. Allow access to printer. We're going to save this. Now, we can actually select 3 things at once. Of course I missed something. And then we're going to move it above this rule. And watch, you can actually see all 3 rules will jump up there. And I'm going to go back and fix another mistake. I forgot to pick a source, the IoT net. Okay. And it stands out pretty easily in that rule set. I could see it with apply changes. Okay, we're almost done with the rules. We got the guest network. So we're going to do, I want to start down here with private networks. We're going to do guest network. We're so close. It takes a lot longer when you're trying to describe it as you're doing the video and walking through everything. If you just go typing this stuff in, it'll go a lot quicker if you are just typing it in without talking about everything that you're doing. So I'm trying to be a little bit detailed here, so just like my written guide, so you can actually see what's happening and understand what's going on. Guess not. So we got to take just the guest. This is our usual stuff. Oops. Destination. I want it to be. I accidentally clicked the wrong thing. Address. Okay. And for the guest network, we're gonna allow it access to printers. So your guest can print on your printer. You may or may not want to allow that, but if you want them to print on your printer, if you trust your people in your network. So we're going to pick protocol, TCP, UDP, and then we're going to pick source. We're going to pick guest network and destination printer. We could have copied the printer rule probably across the networks as well. I just thought about that, but it's not too big a deal, I guess. Allow access. It just takes a little bit longer. Right, so just to think about it, you can copy any rule that you want. Okay, so what I did for the IP camera network is I actually only copied the DNS rule. And the reason I did that, which I explained in my written guide, is it just to reduce spam in the firewall logs, basically, because it's always requesting DNS all the time, and you block everything. Like a lot of devices will keep calling out. So to reduce that kind of spam and that extra traffic of checking for DNS, I actually just allowed DNS, but I don't allow anything else. So it still can't get out. It can just get the IP address of where it wants to connect to, but it can't actually connect to it. So that kind of appeases the devices, This is nice because it kind of reduces a little bit of spam and maybe a little bit of network traffic as well. Because some devices keep trying and trying. All right, so now this completes the firewall rule configuration. And so this actually completes all of the configuration that we're going to do for OPNsense as far as the basics of what you need to do. There's a lot more things you can tweak and add, but this was like the bare minimum. We set up a couple of system settings that you want to configure about your system to customize it for your network. We set up the interfaces, we set up the LAGG, right? And then we set up the VLANs. We set up DHCP, V4 and V6. And then after that, we did a little bit of Unbound DNS configuration to allow host names to resolve the IP addresses. I also talked about query forwarding in case you're connected behind another router. And after that, we started working on creating aliases that we're going to use in our rules, firewall rules. And then we created all the firewall rules we needed for all of our interfaces. So with all that said, that's just the basics. There's a lot there. That's why this video is so long. But there's just but I wanted to go over that. I want to try to keep it cohesive as possible and focus on just the core aspects. Follow-up videos, I can maybe do some more security related stuff, because there's just so much. It takes hours and hours, right? So this is the most lengthy portion of the setup of your network, because there's a lot of stuff to configure on your router or firewall appliance to get everything set up, the basic network services all set up. I hope you found this portion of the video very helpful. You know, it's long and detailed. This is where a lot of people get maybe hung up on some things. So I'm hoping if you're new to this, that this will, you'll find it beneficial. And my written guide has more details that I go into a little bit further than I do in this video, just because there's just so much there. It takes a lot of time. So you can check that out as well. I'll have a link below. But yeah, until the next time, I'll see you in the next video.